quick video to demonstrate the capabilities of Baumer's OXM laser 2D profile sensor with measurement tools. In this video, I plan to show you how quick and easy it is to set up on rounded tools and also in combination with other objects in the same field of view, straight lines, to be able to do distances between objects, etc. So all you need to get started is to connect the I/O cable here for your inputs and outputs, your Ethernet cable or power over Ethernet cable to do your communication, and connect to your PC to then set up the tools via the web interface. Okay, so to connect to the sensor, all we do is type in the IP address to access the web server connection and access the tools. Okay, so we start off by going into the parameterization, and you can see here we can see the actual profile of the top of the cylindrical product here and also the edge of the other product that we have there. Let me just access the full profile there, and now I can have a look at what the profile looks like and make some adjustments if necessary. So again, we can just optimize the exposure time of the sensor to give us the best results. We've got a nice good profile here. Okay, let's do some measurements. So go to the measurement tools, go to the circle tool in this case, and let's say we want to find out what the diameter is of the circle, and maybe say what is the distance between the center of the circle to, say, the edge of the part here. So the center of the cylinder here all the way to the edge of the tool here. Okay, so let's go ahead and add the tools in. So in the circle tool, automatically diameter is selected. We want to know where the center in the x-axis is, so let's select that. And then we can add the edge position of this target here. So we change the field of view like so, and you can see that the tools are highlighted here of where it's found one edge to the other edge, and then it's giving us this hashed line of what it believes the edge to be. And also for the circle tool, this little X point of where it believes the center of that circle is, and also what it imagines the diameter and the circle looks like for that part. So if I was now to change where the circle is, you'll see the profile changing there. And also if I am to change the edge of where the part is, you'll see that there. And of course I can expand the field of view out to give us a greater area to look over. If I do the same for the circle now, I can say anywhere from here to here. Okay, so these are our outputs here that you see. So we've got our circle diameter of, say, 27 mil almost. The center of the circle here is around 8 mil left of the sensor center, 8 mil, sorry, and the edge position is 21 mil from the center of the sensor emitting laser. Okay, so like I said, we can change those dimensions here live, and you can see the output that it's giving. Okay, so we can now assign some outputs to this, and also on the cylindrical part I have changed the diameter along it by adding different thicknesses of tape. So you can see without tape I'm getting around 27 mil, with a few layers of tape on it, 28 mil measurement, and then with a single layer nearly 28 mil. So nearly 28 mil, 27.2 mil roughly, and then just over 28 mil, 28.2 mil for that there. Okay. Okay, so now we can make the measurement as explained at the start, from the center of the circle measured to the edge of our part here. And there's no defined tool for that, so we can use our auxiliary tools, and we can choose, say, the right option. In this case it would be the distance in X between the center and the edge of the part there. Okay, so we go into our caliper tool, select the source, and yep, in this case it's the center of the circle, and then to the edge position, and you can see it is now measuring the distance there. And if I now go to move the part, you'll see how that distance changes. So the distance goes from, say, at that point 33 mil down to a few mil difference. There we go. Okay, so now we can make some thresholds and assign the digital outputs to the measurements. So we've got two digital outputs we can use, and also the analog output. And of course you can output the profile in interpolated form with spacings defined, or just the raw data as you see it. Okay, so let's assign output 1, say, to the diameter of the circle there. And so we choose the correct tool. You can see output 1 appears here, and on, and we say it's active low, and we want to give an output as soon as the diameter is, say, over 27.4 or 27.5 mil, let's say. Okay, so we assign that there, and let's set the hysteresis a little bit lower, say to 0.5 mil, for example. The second output, we can say we want to pass or fail depending on how far the center of the circle is from the edge of the other component in view. So we go to caliper X distance, which is this now, has added output 2, and we can now set the threshold to say anything more than 20 mil, give us a output for that. And again, let's change the hysteresis there. And we can do a little bit of a test now. So for output 2, it's under 20 mil difference, it's over 20 mil difference, under 20 mil difference. And if you look at here, output 2 illuminating, we can use this here for pokey oak on a part as it moves in and out. So you can see the output going on and off when out of tolerance and then when in tolerance. We have also set up the tolerance on the circle diameter as well. So we can have a look now at output 1. So there you can see it. It is on the original taught or defined diameter. If I change it now to a slightly larger diameter, we've put some tape on it, we're up to 27.6 mil. There, still okay. If I now do it to a diameter which has much more tape on it, you can see output 1 has now been activated because we're up to 28 mil there. So output 1 is on. If I go back to the original thickness here, you can see the output goes off. If I now bring the parts closer, both outputs are off. So there we go, nice and simple setup on how to do some dimensional data and do some quick pokey oak and use the digital outputs.
So just to summarize, you can use the Baumer's multi-tool profile sensor, the OXM laser line sensor, for lots of applications, dimensional checks using cylindrical objects, solid objects with defined edges for measurement, and pokey oak. You've got the access of 2 digital outputs, an analog output, and of course you can output the whole of the profile. You also have a large selection of interfaces and protocols, Profinet, OPC-UA, etc., etc., all free and easy to configure via the web interface as shown.